Okay, so hello guys and welcome back to the series. In this series, we will build a CDN from scratch in Go, and this is the first video in this series. We just had our 0th video, which was just kind of like why you should build it. And in this series, we will build the first building block of a CDN, which is a reverse proxy. So what a reverse proxy does is it accepts the request from the client machine and it just forwards to the backend or wherever the origin server is. So it's kind of a dumb CDN. It does not caches the it does not caches the response. It just forwards the request. So for our part one or the milestone one, we will try to build a reverse proxy in Golang. So let's talk about like the system design of a reverse proxy. So to build a reverse proxy, we just need to open a port here, which will accept the request from the client, and we need to open a port here, which will which will forward this request to this backend. And if we need to parse this request to know some things. For example, when we will build a CDN, we might be interested in the HTTP headers. For example, connection keep alive and the get request. So we might parse this request, store some values in our reverse proxy, so that when next time this request comes, we can cache it and we can just forward it to the backend. But in the first milestone, what we will do is we will just accept the connection and forward it to the backend. And it will be a simple reverse proxy. It will not do any caching or something like that. And from there on, we will build the CDN on top of this reverse proxy, so that there are like milestones and you guys don't get bored and we complete this project. Okay, so for this video, I just told you like what a reverse proxy is. Now what we will do is we will open this port here, and we will accept the raw TCP connection and like print out how a TCP connection looks and how the HTTP request looks in plain text. Okay, so let's just let's just name this project as Cachify, and now just open the VS Code here. So we have the VS Code. Okay, so let's talk about the dependencies for this project. I would suggest you to use Linux for this project because like opening a TCP port is much easier in Linux than in Windows. There might be different APIs, but you can also do that on Windows, but like do that on your own. Like you have to research some things. And for the Golang, you just need to have the Go version Go version 1.26. Just download the Golang from Golang official website. It's just a simple command, and then we are ready to go. And for the code editor, we will be using VS Code. Okay, so let's just initialize the project. Yeah, this is the command to initialize a new Go project. Just like npm init, it is Go mode init and Cachify, which is the name of the project. So it made a Go mode file, which is something like a JSON file for the node people. So let's just make a main.go file. This will be our main function, our entry point, and we need to specify this by writing package main. Now let's define a function main, and for now let's just print hello world. Now just let's run this file. To run a Go file, you should just like go run main.go, the name of the file. So it printed the hello world. So you guys can set up everything and just print hello world, and from there on we are ready to go. You just need to download Go in your machines and just open VS Code and Go mode in it and just print this hello world, and you can just, if you see this here, then we are ready to go. Okay, so let's just make it server started. Okay, so let's just open a TCP connection, and for that we would need this. Let's just name it listener dot listen, and here we will give the type of connection to accept, because there are two type of connections, TCP and UDP. So on this port we will accept the TCP connections, and for the port number let's just say 3000, but I need to write the full port number, so let's just say what's the full port number for local host 3000. mm, yeah, this is the one. So or maybe something else. Yeah, I think it should work. So we just copy this thing and just paste it here and just put this. So we have opened a port on port 3000 of our local machine. And in Golang, for example, in Golang, this thing will return two things, net.listen. It can either open a port successfully and give us this listener variable that will listen on that port, or this line might break and it might not be able to open that port. For example, if that port is being used somewhere else, or if there a system failure, then it might return a error to us, which will be stored in this variable. And this this operator is used in Golang without defining the types of the variable. It can assign the types in the runtime by like fetching the types from what we are assigning to it from here. For example, this net.listen might return the net.listener type. So Golang in the runtime will assign that type to our variable. So if we have used, so let me just show you. If we have used net.listen TCP 3000. Yeah. So if we have used equal to instead of that variable, then it says that undefined, because compiler cannot like comprehend the type of this listener. So what we use, if you want to do equal to, then you should define the type here, just like you do in C or Java. But we can just use this operator and it will automatically define the type. And now that error is gone and another error is coming that says that declared and not used. So in Golang, if you are not using a variable, then it will give the error. So let's just use this error variable. It's not equal to null. Then just empty.println cannot open the port at 3000. And so the error from the error variable is gone because we are using it. So now let's just also use the listener variable to accept the connection. So let's just make a connection variable and it will also return an error. And now let's just say that listener dot accept. Okay. So what this thing will do is it will accept the request. And after that, we can read from this connection. It will accept that request and it will give a connection variable to us. And now we can read from this connection variable. So how everything happens behind the hood is like pretty deep. So what happens is when a TCP connection came, that connection is stored in the network stack of the machine. And this connection variable, this is a pointer. So if I hover over it, so this is a net dot connection variable, and it will point to that like it will point to that area where our request just came. So this connection variable, from this connection variable, we can make a reader which can read from the network stack of the operating system. So let's just make a reader. We don't need a error for this one. So buff.io dot reader, and we can just pass the connection variable here. Okay, so mm, there might be something else we are missing. Buff.io buff.io dot reader. Okay, let's just search on Google how to read from connection in Golang using buff.io. Buff.io dot new reader. Okay, so it was actually new reader, the function name, and now we can just give this thing to this. And now, as you can see, we have a reader. So what this thing did was it just gave us the buff.io, and it just gave us a new reader, and we just passed the connection variable to this. And what this reader really is, it is just a pointer to a memory of type buff.io.reader, which is an internal Golang type which Golang have defined. So this reader is same as reading from a file. For example, a file is present in your local operating system, and you want to read that file. So this reader, which is reading from a network, and a reader which is reading from a local file, both are same things. But there is a difference that the data from network is not there in your local machine. So the data is coming in the network case, but the data in the local case, it is already there. That is the only difference. So you guys can just remove the phobia of networking and everything from your minds, and can just think of a network as a reader, as if you are reading from a local file, but just the files are not present there yet. It is coming continuously. That is the only difference between a network and between a local file. So if you like want to go deep, you can just like search how to read a file. Like, okay, so let me just show you how to read a local file in Golang. Okay, with the buff.io new reader. Yeah, so as you can see here, so this reader, which is reading a file from local machine, it is the same as reading the file from a network. In this case, we are passing the address or the pointer to the file here. And in our case, we were just passing the connection to this function. So it's just pretty simple. And now we will read this, and let's just create a buffer, which will be just an array of bytes, which will read it. Okay, so let's just keep it as 4000. Yeah. What's this? Expected operand. Okay, might be like this. Yeah. So what we have done now is we have created a buffer, which is just a variable of array of bytes. So we have allocated a memory of 4 kilobytes, 4 4000 bytes in our memory, and we have just got a variable for this. So now what we will do is this is a reader. This is a reader, and this is a location in memory that we have like asked from the Go compiler. Like I need 4000 bytes of memory. So what we will do is we will just read this reader, like read from this reader into this memory so that this request, the TCP request that will come here, can be came in my local machine. No, can came in my local like in my program. So what we will do is we will just read and reader dot write to reader dot read bytes, and we will just pass the buffer here. Okay, so this thing is mm, so so let's just see what this thing expects. Okay, so the read bytes accept a byte, and it also accepts some error. Okay, so let's just Google this thing. How to read to a buffer from a buff IO reader. Golang. Okay, so the method I used was wrong. It's just simply the read method and just this. Okay. So now we have this buffer stored in our program, and this buffer has read it from this connection, and now this buffer is available in our program. Now let me just print this buffer. Okay. So let's just print ln this buffer, and let's just see what happens. So let's just do go run main.go. The server started log came, and now it stopped on this listener. It stopped on this listener.accept. It opened a port here, and the listener is waiting, and listener.accept is waiting because there is no request on this port. So let me just send a request on this port from my Google, from the Firefox. Okay. So let's just send a request to 3000 port because, okay, so now I'm sending a HTTP request to the 3000 port, but HTTP is built on top of TCP. So automatically a TCP request will also be sent. Like HTTP request is carried by the TCP request. So if I send a HTTP request here, a TCP request will also be sent. So let's just send this, and it says looks like there is problem with this side. So let's just see what the console was. Okay, so this was the console, and what it is giving is this is the size of the buffer, and this is the address from where we can access this buffer. Okay, so let me just change a few things in the console. Okay, so let me just change a few things in console so that you can see what is coming. Because right now, this buffer is returning the first address of this array, of this buffer array, and it is also returning the size of this buffer array. So we can just read from that, like for example, let's just run it again and let me just show you. So this is the number of bytes we need to read, and this is the first address of this byte. So we can just read these number of bytes from this address plus 4000, just like we read in array. So let me just do one thing here. Let's just do this and read up to 4000. So now let's just see what happens. Okay, it's still returning this. Let's just change this function. fmt.println, and now let's just print this thing. Okay, so now finally we see the bytes coming. Okay, so let's just see why before that this was not working. So why this was not working was because this is a different implementation of print function. This is a different implementation of print function, and this is a different implementation of print function. So if I write this, this is just printing the number of bytes that are stored in an array and the first index or the first location in the memory. So to print using this function, we would require a for loop, just like we print the whole array. For loop and just like print this int I is equals to 0 and just print like the whole 4000 bytes one by one. But we can also use the fmt print method that just print a array using just prints the whole array for us. So what I did was I just used the fmt.println method and just print the whole array. Now let's just see the output. What was the output? Okay, so this is pretty interesting. So as you can see, our first log is here, server started. Okay, so after that, there is a array. You can see this square bracket and the array ends here. So this is just the array that we printed, and the size of this array is 4000. And at each element of this array, there is a byte data. So what is a byte? Byte is like minus 127 to 128, something like that. And in some cases, if it is unsigned, it can be 256. So this is just the bytes that are getting printed. So whenever a HTTP request come, so from this you can like understand how things really work inside the hood or behind the hood. So whenever a HTTP GET request came, what our server do is it opens a TCP port and it waits for the connection to happen. And then when the connection happens, the client will send raw bytes to our computer. These are just raw bytes. We don't know the meaning of these things. Like, what are these things? These are just raw bytes. There is no HTTP here. There is nothing else. It's just connection between two machines and exchange of raw bytes. That's it. And then what happens is we have HTTP parser libraries. For example, in Go, we have the net HTTP parser library. In JSON, in JavaScript, we have the Express library, which parses these requests. So for example, what that library will do is, or what Express or what any of the library that handles HTTP will do is, it will just convert this thing into string. It will just convert this thing into the string and it will just make sense of this thing. So let's just see. So after converting this to string, this is coming. Server started. This thing will come after we just what we did was we just converted this thing into string. Now just let a better look at this. Okay. So this is the row request that will came. It did not have any functions. It don't have any middleware. It don't have nothing else. It don't have any parameters. It just have this raw text. And now the HTTP parser libraries like Express or the net library in Golang, it will parse these requests and it will store them in structs. And then you can just access these things. For example, if this was the request, and after parsing, you can just access like request.params, and it will give you the parameters. But to do that, an HTTP parser library need to parse these requests and store them in the structs so that you can do that. So Express does nothing but parses this request and store them in the struct. That's everything. That's all that Express does. So for our proxy project, what we have done till now is we have opened a port at 3000 and this port is doing great. We are receiving the request from the client. And what we need to do now is we need to forward this request to a origin server. Okay. So now before that, let me show you why this browser is saying like looks like there is a problem with this site. So why this browser is saying that? So for browser sent a GET request. And in our code, what we did was we just print that raw TCP connection. We did not send a response back. So that's why browser is like this connection accepted my request, but it did not send any response. So there is something broken. So as you can see, the browser is showing error. So let's just try to fix this error. And let's just do reader dot. Okay, how can we write? Okay, so let's just Google because I don't know the functions to write to this connection. How to write string to buff IO reader in Golang. Strings dot reader. Okay. Strings dot new reader my string buff IO dot new reader buff IO dot read string dot print line. Okay, this is not the thing that I was looking for. My string strings dot new reader my string. No, no. How to write to acha, okay. So this is a reader, but we need to write to the connection. We cannot write to a reader. So what we will do is we will just write a raw HTTP response here. So let's just ask ChatGPT to write this response. Write a raw HTTP hello world response. Okay, so this is the response. Connection. Okay, yeah. Let's just write this thing. Now let's see what happens. Mm, okay. Yeah, we need to do this thing. Connection dot byte. Okay, so okay. Let's just have a response variable. So this is our response variable that we will send, and let's just write. Let's just convert this response variable into byte because the connection expects to have row bytes instead of the like string thing. So let's just convert this thing into row bytes and just send it over the connection. Okay, so what we are doing here is we just have a response variable. This is what your Express will write. It will just say HTTP 1.1, okay, content type, content length, connection close, and it will have a hello world in response. And what we are doing is we are just using the same connection that we accepted the request with, and we are writing to that connection with this response by converting this response into bytes. Okay. So let's just do that. Now let's see what happens in the browser. We got a hello world response. Okay. So this is how your Express works. This is how like every HTTP parser library works. And this is like a really good way to understand like how things work behind the hood. So let's just remove the response for now. Let's just remove this response also, this connection dot write also. And let's just build a new server which will act as a origin server. Okay. So because in this thing we just okay, so we have completed the goals for this project, but let's just keep going. Okay. So in this thing, what we will do is we will build our backend that will be a simple server in Go that will just return GET request. Okay. And what will be our goal is to forward this request from here to here to here. So we accepted that connection. Now what we need to do is we need to forward this connection to the backend. And then what will happen is the backend will respond and we just need to copy this connection and just send it here. This is how our reverse proxy will work. And we need to do that in an infinite for loop. As you can see now, this is a single thing. So once a single request came, it does its thing and it just stops. The program just ends. So we need to do that in an infinite for loop so that it can run infinitely. So let's just do this thing. Let's just build a slow server or a main server. Main server, go mode main server, touch main.go, and we have this now. So I just did go mode in it and touch main.go to create the main file. And now just do package main and let's just copy this code from ChatGPT because it's just a simple GET request. So write a simple HTTP server in Go to respond with hello world for a GET request. Okay. So this no 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 no. So it wrote the for loop. We don't need this thing. We don't need this thing. We don't need. Just use the HTTP library. Yeah, yeah. So this will be good one or even shorter. Yeah, this will be good. This will be good. So let's just do this and now let's try running this thing also. Mm, ls main.go go run main.go. Now let's just send the request here. It should say hello world again, but it did not say that. So okay, so the port for this one was 8080. Yeah, so it is sending hello world. So this server is working fine. So let's just send this request from our proxy. Okay. So let's just define a variable. Let's just find out the type of this thing. Is it string? Yeah, yeah, it is string. So let's just do origin server will be this. Just copy this thing